Hi there, everybody. This video is on quadrilateral properties, and really it's about what can we prove about the different quadrilaterals. We got parallelograms, kites, we got a rhombus here, rectangle, trapezoid, isosceles trapezoid, and square. And you may think you know a lot about those shapes based on what you've done in previous classes. Your teachers may have even told you some things that they thought to be true about these shapes, but I guarantee they never really proved that they were true. And that's what we're going to go through in an informal way today. And some of this stuff you've already proved if you did the previous learning target, which were triangle and quadrilateral proofs. I'll reference that a little bit as we go on. So first of all, let's start with parallelograms. What is the definition? The definition of a parallelogram, and I'm not going to say that it has to be four-sided, but I'm going to say that all of these they have to be four-sided figures. These are quadrilateral properties. We're not talking about pentagons or triangles or anything else. So for all these, they have to have four sides. And for a parallelogram, you have to have two pairs of opposite sides that are parallel. And that is the definition. Everything else that you think you know about parallelograms is something that must be proven. Okay, and we're going to go through that kind of informally down here. So what can we prove about it? Well, let's put in our definition. Let's draw a diagonal, and this is a proof that you did or you should have done anyway, for the last learning target. We proved that these two triangles were congruent. Since the top and the bottom are parallel, this angle and this angle are the same. Since the left and right are parallel, this angle and this angle are the same. The two triangles share this side, so the triangles are congruent by angle, side, angle. That means all the corresponding parts are congruent too. So this angle is equal to this angle. Now, if we drew the other diagonal, we could prove that those two triangles were congruent, and we'd be able to then say that the other pair of opposite angles are equal too. So one of the things that we've just proven here, in an informal way anyway, are that opposite angles are equal. So if this one's 60, this one's 60. This one's 100, this one's 100. Opposite angles are equal. Now, because these triangles are congruent, we also know that the corresponding sides must be the same too. And that's something you might say, well, I knew that, but you never proved it. You can't make claims without going about proving them. So those opposite sides are the same too. Opposite sides are equal. What else? Now, because the top and the bottom are parallel, this big angle here and this big angle here, those are same side interior angles. And so they have to be supplementary because they're same side interior. So these angles and this angle here, they're supplementary. They have to add up to 180. So if this is 80, that one's 100. We can say that adjacent angles are supplementary. So any two angles that are next to each other in the parallelogram, this big one and this big one, this big one and this big one, they have to add up to 180. The top two have to add up to 180. Let's draw the other diagonal in here. So another thing that we can prove, and I think we've talked enough about the proof, so I'm just going to tell you this one, is that the diagonals in this parallelogram, they bisect each other. They cut each other in half. So this little part has to equal, oops, let's put 3 on there, that little part. And the other one is cut in half too. 1, 2, 3, 4. 1, 2, 3, 4. Those diagonals bisect each other. They cut each other in half. Diagonals bisect each other. And that's there's a few little minor things that you could prove too, but these are the big ones that we can prove about the sides, angles, and diagonals of a parallelogram. Let's move on to kite. A definition of a kite is it has two sides that are equal, that are right next to each other, and the other pair of sides are equal as well, but they're not equal to the first two. And it looks, if you turn it like this, it looks just like a kite that you might fly in the sky. So what can we prove about kites? Again, some of this you did in the part of the last learning target. For example, I think this was one of the proofs that you did in the last learning target. We know these sides are the same, these are the same. The two triangles share this side. That means the triangles are congruent by side, side, side. And so then we have a pair of corresponding angles that have to be the same. Now, these two, you could try to prove that they were the same, but they're not. So it has one pair of opposite angles that are equal. One pair, not two pairs like the parallelogram. It had two pairs of equal angles, just one pair for a kite. Another thing that you can prove, which I believe you proved in the previous assignment, was that these diagonals have to be perpendicular. They have to meet at a 90-degree angle. Now, I don't want to write out the word perpendicular every time I have to say it or refer to that concept. So in geometry, we often have shortcuts for writing things. And this upside down T means perpendicular. So every time you see that upside down T, it means perpendicular. So this just means the diagonals are perpendicular. Another thing, because those two big triangles that we had here before are congruent, that means this angle and this angle are the same because they're corresponding parts. That also means this angle and this angle are the same. Again, because they're corresponding parts. We showed the triangles are congruent. Congruent triangles have congruent parts. So now, this diagonal doesn't do that because this angle and this angle aren't the same. So this angle doesn't cut these in half, but the long one, the long diagonal, always does. So we'll say the long diagonal bisects opposite angles. Bisect means cut in half. Another thing we could prove is that this short diagonal is cut in half by the long one. Now, the long diagonal isn't cut in half. We can see that one's shorter than this one. We would have a hard time proving that those two have to be the same for a kite. In fact, you wouldn't be able to. So one more here. Short diagonal. You know what? Let's write long diagonal bisects short diagonal. There we go. So the long diagonal cuts the short one into two equal parts. Okay. Let's move on to our next shape. Let's move on to the rhombus. So the definition of a rhombus is four equal sides. Any shape that has four equal sides is a rhombus. So that is the definition. So what else can we prove? Well, let's see what happens here. I'm going to draw one of these diagonals. We can show that these triangles are congruent by side, 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 because they have this shared side here. And these triangles are also isosceles. So they have two equal angles. This angle equals this angle because they're isosceles. Now, because the two triangles are congruent, the corresponding angles have to be the same too. So we've actually got four equal angles here. I'm not going to write these out in words like I did the other one. I think you've got the idea, hopefully, with that. Now, since this angle, and this angle are equal, and they're alternate interior, that means this side and this side have to be parallel. Similarly, this angle here and this angle are equal. They're also alternate interior. That means these two sides have to be parallel. Well, that looks like a parallelogram. It's got two pairs of equal angles. So since a rhombus is a parallelogram, that means all of the parallelogram properties are also true about a rhombus, with some things that are extra, which we'll talk about in a second. But so we can add all these parallelogram properties, like opposite angles are equal. In fact, let's do this. Let's turn that into one. So those two big angles there are the same. These two big angles are the same. The diagonals bisect each other. That's true about a parallelogram, so it's also true about this because it's a parallelogram. So those are all the same. The diagonals, they bisect each other. Oh, yeah, we just said that. And earlier we proved that let's see, it's going to get a little messy here. I'm going to call these angle 1, angle 2, angle 3, and angle 4. The measure of angle 1 equals the measure of angle 2 equals the measure of angle 3 equals the measure of angle 4. Those are all the same. You know what? I should have just left it. Let's leave it like that. We can tell these two angles are the same. And then these two angles are also the same as well. So there's lots of stuff. Now there's actually some other stuff. We see that all four of these triangles, we can see all four of these triangles are congruent. All four of them have a 1 hash mark, 2 hash mark, and 3 hash mark side. 1, 2, 3, 1, 2, 3, 1, 2, 3. So they're all congruent by side, side, side. And they all meet right here. We've got 4 angles that have to be the same because they're corresponding parts of congruent triangles. Congruent triangles have congruent parts. That's the thing you use for the reason in the proofs. So those 4 have to be the same, and all the way around this point is 360. So if these angles are the same, and together they add up to 360, that means they're all 90 as well. So those diagonals have to be perpendicular. And that is just about all of what we can prove about rhombi. Let's look at rectangles. A rectangle, definition: 4 right angles. So this is 90, this is 90, this is 90, and this is 90. One thing that we already proved about this was that the diagonals, and this you did in a previous lesson, is the diagonals have to be equal in length. So this side and this side have to be equal. Now, you notice this is 90, this big angle here is 90, and this is 90. Those are same side interior angles that add up to 180. That means that the top and the bottom have to be parallel. You can use similar reasoning with these two angles to say that those are parallel. So a rectangle is a parallelogram. That means everything you know about a parallelogram is also true about a rectangle. Opposite angles are equal. We said that already. The diagonals, they bisect each other. Now, these diagonals in a rectangle are equal in length, and they're cut in half. So all 4 of those little parts have to be the same. Opposite sides are equal. That's something that's true about a parallelogram. Also true about a rectangle. So those are all the same. And that's about it for a rectangle. Square. Let's look at a square. What is the definition of a square? Well, we need 4 90-degree angles, and we need 4 equal sides. So 90, 90, 90, 90, equal, 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 equal. Okay, so it has 4 equal sides. Well, that meets the definition of a rhombus. So all this stuff that's true about a rhombus is also true about a square. Now, it also meets the definition of a rectangle, right? This has 4 right angles. That's the definition of a rectangle. So all the stuff that's true about rectangles is also true about a square. Whew, we got a lot of stuff to go, a lot of stuff to write in here. Let's see, we got parallel sides. Parallel sides. We got diagonals that are equal and are cut in half. It's a rhombus, so the diagonals are perpendicular. Oh gosh. We can also show that not only are these angles the same, but they're all 45 for a square. So this is 45, 45, 45. All these are 45s. Oh boy, that's a lot. And that's about it. That is all the rectangle and rhombus properties that we know. Last pair of shapes are both trapezoids. The definition of a trapezoid is two parallel sides, and those two vertical lines means parallel. At some point, somebody got sick of writing the word parallel and said, you know what? Two vertical lines means parallel, so that's what this means. Two parallel sides. So here, parallel sides. There's not a lot we can prove about trapezoids in general, but there is one thing in particular. Since these are parallel, these are same side interior angles, and we know that they have to be supplementary. So if this one is 60, then this one is 120. Same idea for the other two. Those angles have to be supplementary. So if this one was, I don't know, 30 degrees, this one would have to be 150. You have to add up to 180. And that's about all you can prove about trapezoids in general. Isosceles trapezoid, definition is two parallel sides. There's that symbol again. And the other two sides are equal. So these two sides are equal. These two are parallel. There's a couple different things you can prove about these. Just like isosceles triangles have two equal sides and two equal angles, there are some equal angles in isosceles trapezoids as well. In fact, there's two pairs, and they look like that. These are still supplementary, like we said, because for the regular trapezoid, and that is about it. Make sure you have this thing filled out. It is one of your assignments. If you need some help, let me know. Bye.
Do you have a test today?
Every day.